Hello and welcome back to the channel. Thank you for coming back if you are a returning subscriber. If this is the first time you're coming across this channel, well, thank you. And we entreat you to subscribe. Um, Hit on the like button, share the video, and notify your friends about this particular CAD channel. All right. So let's dive straight into today's video. Today's video is in two parts. The next one will come in the coming days, but for the first video we are going to focus on the theoretical aspect of development of surfaces. Right, so in engineering drawing, one of the topics that you come across is the development of surface. So we are just going to run through what development of surface is, what we talk about it, what does it mean, and how do we go about it, and how can we use our CAD software to be able to, you know, draw surfaces or develop surfaces of solid figures. All right. So let's dive straight into the video. So basically, when we talk about development of surfaces, we are looking at the spreading of, solid surfaces. All right. So sometimes they call it development of solids or development of surfaces. Right. So if you have, let's say, a cone, okay, a solid cone, and you want to develop the cone, what we are trying to say is that you are going to spread the cone, all right, the solid cone, you cut it at one end and spread it on a flat surface or on a plane, and the shape that you see, you basically draw, right? So we assume that object halo are made up of thin sheets. We cut it open at one side and we unfold the sheet completely. Then the shape of that particular sheet is what we call the development of surfaces. Right? So we have the lateral surface, and the lateral surface is the surface excluding the solid top and base. Okay, and they are basically applied in various applications in engineering. So we have so many products or objects which are difficult to manufacture by conventional manufacturing processes. So what we do is that we use the understanding of development of surfaces to be able to fabricate them. Alright. So if you go into the sheet metal industry, for example, they use this particular approach in developing or fabricating the objects that you want to. So we have examples, we have in the application, we have the boiler shells, we have the chimneys, we have the pressure vessels, trays, boxes, cartons, feeding hoppers, and other ones as well. Okay, so the objective of this particular study is to one, we are going to develop, okay, the surfaces of solids. Okay, we are going to learn the methods of development of surfaces. We're also going to look at the sections and the posture. All right, so let's go into it. But before we go ahead, note the following point: development is different from or different drawing than projections. Okay, the second one too is that it is a shape showing the area, meaning it is a 2D plane drawing. Okay. Also take note that all the dimensions of it must be true dimensions. And then the last one is that as it is representing the shape of an unfolded sheet, no edges can remain hidden, and hence dotted lines are never shown on development. So these are some of the key things you need to take note as we dive deep into development of surfaces. So let's move on to the next slide. So this slide basically has a example of the development that we are talking about, or the solids that we are talking about. So you can have a cuboid, you can have a cube, and you will be asked to develop the surfaces. So this is just the orientation. Okay, so if you have a cylinder like this, and we cut the lateral side and we spread it open, okay, we get a rectangular shape for the cylinder. All right, if it is a hollow, then it means that we'll get only a rectangular shape, but if the ends are closed, then it means we are going to have the circle, one at the bottom and one at the top. We also have that of a cone, And normally when we develop the cone or try to develop the surfaces of the cone, we get the sector of a circle. If you look at the shape, right, of like a pie. Okay. We also have pyramids. So if you have a hollow pyramid, this is how it looks like. And then we also have prisms. So for the prisms, when we spread it open on a plane, these are the shapes that we see. We see couples of rectangles coming together to form the shapes. All right. Then we also have the tetrahedron, which is a four equilateral triangle, and then all of that. Okay. So let's move on to the next one, the forestrooms. Development of forestrom or cone. Okay. So a key thing you need to take note when you are developing a cone is the formula. All right. The angle for the sector. Okay. There is a formula for it, and it's given by R on L times 360. So before you can get or develop the cone, or you can get the sector like we said in the other slide, you need to take note of the R. The R is basically representing the radius of the cone. The L is representing the slant height of the cone, right? Multiplied by 360. So we'll look at a question where we will practice all these ones. But this is just a tutorial or a theoretical tutorial on development of surfaces. We will go into it in the next video. Then we also have the development of a costume of a square pyramid. Okay, so basically have a feel, just look at how the orientation is and how they appear, and you'll be okay. So let's look at the typical section planes or the typical shapes of sections that what we have when we start to develop. Okay, so if you have, let's say, a cone and you cut it in this orientation, that is, the cutting plane starts from the apex to the base, and you get the shape that you will get is a triangle. Right, if you have the cutting plane cutting in this orientation, that is on one side here and the other side here, then you're going to get a shape in the form of an ellipse with respect to looking at it from the plan, right? And when we have a cutting plane in this orientation, we have what we call a parabola. Okay, and for this one we have a hyperbola, and for cylinder too we also get similar that of the cone here, we will get an ellipse, and then for this one we get a trapezium. So different shapes, and we get to see different shapes depending on the solid that we are actually developing. If it is a cone, it's different. If it is a prism, if it is a pyramid, they come in different shapes. All right, so just take a note of the shapes that you possibly generate depend on the cutting plane, where the cutting plane is passing. Okay, now let's go to the section of the solid. All right, so for here we are going to look at how we position the sectioning or the development. Okay, so there are two key things that we normally produce, which is the front view and the top view. These are the two important views that we normally use in the development of solids. All right, the top view and then the front view. Okay, so two cutting actions means section planes are recommended. So A, section plane perpendicular to the VP, which is the vertical plane, and inclined to the HP, which is the horizontal plane. This is a definition of the auxiliary inclined plane, that is the AIP. Then we also have B, the section plane perpendicular to the HP and inclined to the VP. This is a definition for the auxiliary vertical plane, that is the AVP. All right. For now, it might look a bit unclear, but you'll get to know more about it when we start practicing on these types of questions. Okay, the action of the cutting plane is called the sectioning of a solid, and the plane of cutting is called the section plane. All right, so take note of these two things: the sectioning and then the section plane of, of the solid. Okay, so let's look at this one. So this is an illustration showing the terms in sectioning. All right, so you have the front view, we have the top view. Okay, then we also have the true shape. Now take note, we said that this is called the section plane, right? And the section plane is giving us this true shape here, and we also have the view from the top, right? So this is what we call the section lines, telling us that the cutting plane is cutting in that orientation. So this is the effect of of the section that has been done with respect to the top view, or sorry, the front view, right? So the top one is the front view, the bottom one is the top view. All right, okay. So this is a tutorial. A cone with base diameter 40 mm and slide height 60 mm is kept on the ground on its base. An AIP inclined at 45 degrees to the HP cuts the cone through the midpoint of the axis. Draw the development. So yes, so this is an example, and I think we'll cover it in the next tutorial. And so make sure you check out the next tutorial where we'll look at how to solve this particular question. All right, I'll also leave the PDF of this. You can also access it here. Once you click on here, it will lead you straight to the video. All right, so these are more examples in development of solids, and this is a question here, and this is the solution. So this question says that a pentagonal prism 30 mm base side and 50 mm axis is standing on a HP on its base whose one side is perpendicular to the VP. It is cut by a section plane 45 degrees inclined to the HP through midpoint of axis. Draw the front view, section top view, section side view, and also draw the true shape of the section and development of the surface. So basically, this is the solution of the question here, and these are important notes that you've provided. I'll leave the slide in the description box so that you can download it and then get to know more, or revise on your own. So there's also another question that a solid composed of a half cone and half hexagonal pyramid is shown in a figure. It is cut by a section plane 45 degrees inclined to the HP, passing through the midpoint of the axis. Draw the front view, the sectional top view, true shape of the section, development of the remaining part of the solid. Alright, and they're giving you an important note. Take the radius of the cone and each side of hexagon 30 millimeters long and axis 70 millimeters, right? So also for this particular question, this is the solution. So you can basically try on your own to see how best you are getting the understanding. So more examples are there for you to try on, and the good news is that we have the solutions also coming along with it. So after drawing, you can cross check and see if you are okay. So with that said and done, I think we'll come to the end of the video, and in the next video we are going to look at the tutorial question that we saw in the slide, but there are also other questions that you can also solve on your own, and I wish you all the best. Happy learning, and don't forget you can get this slide in the description box, okay, if you are interested in this particular slide. And so I wish you all the best. Don't forget to subscribe, like, share, comment, and I'll see you in the next video. Happy learning.